Good morning, students. With the completion of the first chapter, that was language of chemistry, it's over, and numericals has been done. The exercise has been given, and the exercise is mostly about writing down formulas and the empirical formulas, the molecular formulas, symbols of radicals and ions, all this stuff. And I don't think you're facing any such problems regarding writing symbols, because it's the symbols are there in the book straight away. It's given clearly. You just need to write the symbols of the ions and some formulas. The combinations has been there. So if you have practiced my questions and the questionnaire which I've given to you for solving, and which I also discussed in my previous classes, and in the classwork also I dealt with the symbols and formulas and empirical formulas. So if you are following that one, if you're following that one, then I hope you will not face any sort of problems from chapter 1, the first chapter. In case if you're having any such problems, you can definitely contact the concern any teacher, me or Singh sir, no problem with that. Now, from today, I'll start with a new chapter, the chapter 2, chemical changes and reactions. And if I'm not wrong, this chapter you have already a part of it you have discussed, or rather learned, in the previous class also. So today, I'll just give an introduction, and I'll discuss with some of the portions. It will be a revision to you all, the matters which you already did in the previous class, the portions which you already did in the previous class. So I will be today in the first class of this chapter, so I will be doing just a revision and recapitulation of those portions which you already learned in the previous class, that's class 8. All right, so let's start with the class. The chapter, which definitely the name itself suggests, chemical reaction, chemical changes and chemical reactions. So the first question which will definitely come: what's a chemical reaction? What is a chemical reaction? A very simple word. In simple words, it's a process of bond breaking. Chemical reaction means it's a process by which old bonds or the existing bonds of a certain substance is broken, and leading to the formation, definitely when the bonds are broken of a certain substance, definitely it will lead to the formation of new bonds into another substance. That means one substance is breaking down by the breakdown of the bonds, and another substance is forming by the formation of new bonds. So chemical reaction, it's basically the process of bond breaking with the formation and breaking of bonds from one substance and in another substance, definitely under certain conditions. But there's a point I've added, that's a certain conditions. Why? Because all the reactions, or every reaction, do occur under certain conditions. If the suitable conditions or the favorable conditions are not provided, you also know that favorable conditions, if not provided to a particular reactant or those substances which are undergoing a chemical reaction, then definitely the substance will not react, or the substance will not allow the breaking of bonds for the formation of new substances. Clear? And as I said previously also, that examples, whenever you're giving a definition, examples are must. You should give examples as as the maximum you can. Wherever it's possible, give examples with definitions or any other places which are suitable. All right. The example is given over here. Is given NaOH plus HCl, NaCl plus H2O. As you can see, NaOH means sodium hydroxide. Over here, I've written NaOH symbolical, HCl and symbols NaCl plus H2O. Along with this, it will be much more better and much more informative and helpful, and what should I say, a better way of writing answer, that at the bottom of the base of the compounds, if you can write the names of those compounds. Symbolical, you're writing NaOH plus HCl. Along with that, if you can write the name of these names of the compounds by which these are represented, that's NaOH. Under NaOH you can write sodium hydroxide. Under HCl you can write hydrochloric acid. Under NaCl you can write sodium chloride, and under H2O you can write water. So when you will write these, so a definition you've given, an example you are giving, the reaction, it's a balanced reaction of course by this time, you should be familiar, or you should be habituated by the fact that regarding that balanced reactions are always compulsory. Unbalanced reactions are never accepted in a chemical reaction. So under NaOH you can write sodium hydroxide, HCl you can write hydrochloric acid, NaCl sodium chloride, and H2O water. So that makes a very compact answer. Coming to the next question, that was a very important, that is chemical bond. What's a bond? Bond is basically a force. Bond is basically a force. In the if you can remember class 8 and the states of matter, there was a point with solids, liquids, and gases. The point of difference, that's the intermolecular force of attraction. There was a point which the states used to say that intermolecular force of attraction. Now, intermolecular force of attraction is basically the bond. That was basically the bond, in a chemical bond, which exists within a substance. That means the force by which, what's a bond? The force by which a substance, or rather the atoms or the particles of a substance is held together. It's within a molecule. Within a molecule, atoms are held together by a strong force. Within a metal, the atoms by which metal is made up of, they are held together by strong forces. That's a bond existing within the metal. Within compounds, in compounds, molecules are the smallest particle, and the molecules of a compound, they're held together by a strong force of attraction. So chemical bond is basically the force that holds the atom together within a molecule or in a substance. Now, coming to another point, that is another question rather, it's related to the chapter itself. That is, it is related to the chapter itself. What's that one? That is chemical change. So a chemical change, if you remember, which you read in class 8, a change in which new substances are formed, and what else? The properties of the chemical properties of the reactants and the chemical properties of the product. That means the chemical properties of the substance before the reaction and chemical properties of the substance after the reaction remains unchanged. No, not at all. Gets totally changed. So properties before the reaction and properties after the reaction gets completely changed. That's a chemical change. So new property, new substance is formed, and how we can identify the formation of new substance? That means the chemical properties gets totally changed before and after the reaction. Now, chemical reaction and chemical bonds and other Now, when we are reading, rather doing or discussing about chemical reaction, the things, well, the parameters which guide a chemical reaction, or rather, which is very important to a chemical reaction, is on what ground, what are the conditions which facilitate a chemical reaction. Along with that, on what ground, or what should I say, the parameters which influence, the parameters which leads to the occurrence of a chemical reaction, that we need to discuss, number one. And number two, another point which we need to discuss, that is characteristics of a chemical reaction. That means features. One is on what parameters or which factors to influence are required for a chemical reaction, that without those the chemical reaction will not take place. Another one is what are the features of a chemical reaction, the properties of a chemical reaction. So let's start first with the factors, that how first the chemical reaction, how the chemical reaction will start. The number one is close contact. If you remember, these are the close contact is one of the primary factors, that if two substances are not mixing with each other, are not coming close to each other, they are not rather in close contact, how can a reaction take place? Nothing. When two substances, they are not coming in contact with each other, do you think the reaction will take place? Definitely not. So close contact is one of the very important parameter which leads to the occurrence of a chemical reaction. Hundreds of reactions are there, which maybe thousands of reactions, which demonstrates that without close contact, reaction is just impossible. The examples given: sodium hydroxide, ammonium chloride. If sodium hydroxide and ammonium chloride both solids are mixed together, ammonia gas is evolved. Ammonia gas is evolved. When if they're mixed together properly, and if you want to heat it, you can heat it. It'll accelerate the reaction. Or just if you mix it properly, then definitely ammonia gas is produced and will come out. NaCl plus H2O. Similarly, lead nitrate plus Ki will give lead iodide and potassium nitrate. Clear? Coming to the next point, that is heat. This is another very, very important criteria which leads to a chemical reaction. There are numerous chemical reactions which occurs with heating. Until and unless we are heating a chemical reaction, we are heating compounds, then definitely such reactions will not take place. So until and unless we are heating those two reactants, or a particular single substance or two substances together, reaction will not take place until and unless heat is supplied to them. So heat also plays a very crucial role in in guiding or influencing or bringing out a chemical reaction. So if we heat lead nitrate, what will happen? We will get lead oxide, lead monoxide or lead oxide, nitrogen dioxide and oxygen. This lead oxide, PbO, is having a common name that's called litharge, and its color is yellow. Litharge, lead oxide, its color is yellow. Nitrogen dioxide, color is reddish brown gas. It's a reddish brown gas, the color is reddish brown. And oxygen, a colorless gas. So when we heat lead nitrate, we will get a yellow solid, a reddish brown gas and a colorless gas. The point is the colorless gas will be not visible, because as a reddish brown gas gets evolved, and colorless gas will be invisible. Copper carbonate, if we heat that one, we will get a black residue, copper oxide, and a colorless gas will be coming out. Colorless, odorless gas will be coming out. The next, influence of light. factor. Definitely, light is a very, very important parameter. Many reactions do occur. Many reactions do occur in the presence. Many reactions do occur in the presence of light. In the presence of light. The first very common example is photosynthesis. One of the very common example is photosynthesis. We know that without light, photosynthesis will not take place or will not occur. Another reaction, decomposition of silver salts. Silver salts are highly light sensitive. Silver salts are highly light sensitive. So for that reason, they are probably a question you may get now or later on in class 9 or probably in class 10. But why silver salts are mostly kept inside dark bottles? Because they are light sensitive. In order to minimize the entry of light and to minimize or to the reduction or the the decomposition of silver nitrate or silver salts, they are kept inside dark bottles. Okay, coming to the next point, that is catalyst. As we know that catalyst is a very, very important parameter in guiding a chemical reaction. So you can see nitrogen reacts with hydrogen to give ammonia as a Haber's process. If you remember Haber's process, iron acts as a catalyst. Hydrogen peroxide, water plus oxygen, breaking down of hydrogen peroxide into water and oxygen in presence of manganese dioxide, which is acting as a catalyst. Now, I have seen students, one other very important thing which I want to mention over here, that I've seen students who write, rather during exam time in their answer scripts, that if the question asked that give an example of catalyst, they write iron, they write manganese dioxide. That's absolutely wrong. That is absolutely wrong. Manganese dioxide and iron are only catalysts. They're absolutely wrong. Because there are hundreds of reactions where iron acts as a reactant. Iron is a reactant. It's not at all a catalyst acting over there. Manganese dioxide, there are numerous reactions where manganese dioxide itself reacts. So whenever you're giving an example of catalyst, please, I request you, do give the entire reaction, along with that the name of the catalyst. Then your answer will be correct. Otherwise, only iron, only manganese dioxide, you will write as an example of catalyst. Please, not accepted. So it's better to write the entire reaction, and followed by that, with that particular reaction, which substance is acting as a catalyst over there, you mention that one. That will be the best way to address or give an example to catalyst. Coming to the next, it's electricity. That's another parameter. There are the reactions which do occur when electric current is passed through them. For example, decomposition of water. Liquid water can be decomposed into its respective constituents, hydrogen and oxygen, by passing electric current. And so it gets decomposed breaks down into hydrogen and oxygen gas. So water gets decomposed by passing electricity. The next is pressure. A similar example with this Haber's process. This is a very fine example because the role of pressure in this example, it's undoubtedly important, because without such high pressure, because nitrogen is an inert gas, and hydrogen, though it's an inflammable gas and a bit reactive, but the problem is if it ignites nitrogen in the environment of nitrogen, hydrogen cannot burn. So the conditions need to be changed, and hence it has to be an adverse, a very harsh conditions has to be, and that's one of the example is, no other condition is greater than 200 atmosphere, greater than the greater pressure. such high pressure facilitates the combination and the reaction of nitrogen and hydrogen together to form ammonia gas. Haber's process, the industrial production of ammonia gas. Coming to the final point, that is solution. Coming to the next and the final point, that is solution. Now, solution is another important point which facilitates the occurrence of a reaction. There are many reactions and hundreds of reactions which will not take place, which will not occur if they are not combined in the solution state. You can see over here KCl and silver nitrate giving potassium nitrate and silver chloride. So KCl in the solution state, silver nitrate in the solution state, and we will get the product potassium nitrate and silver chloride. Potassium nitrate, that also will be in the solution, and silver chloride precipitates out. Now over here I want to mention another one important point, that is, you may find some reactions, 1 or 2 or 3, you may find that with the reactions are not balanced. Basically those reactions are not balanced. It's not totally intentional, but basically I overlook those things because the reactions which were involved are rather given as a token of example, rather in demonstrating the particular parameter or particular feature. For that reason, it got just skipped out. But it was basically focused on explaining or demonstrating the process which I was explaining. But do remember, unbalanced reactions are not at all acceptable in chemistry or in any answer on the exams. Do not write unbalanced reactions. It's not that I've written so you will also write. It is basically I was explaining, but in the exam during practice time, when you are writing answers, every time reaction has to be balanced. Completely balanced reactions required. Now coming to the next one, that is now features, the characteristics of chemical reaction. The characteristics of a chemical reaction. There are certain characteristics, features, we all know that. The first is evolution of gas. It's one of the characteristics of a chemical reaction. Evolution of heat, another characteristic of a chemical reaction. Formation of precipitates, another feature of a chemical reaction. Then, what should I say? Then color change, another important feature of a chemical reaction. Change of state, that's another parameter. So let's continue. Evolution of gas. We know that feature means if a gas gets evolved from a chemical reaction, it signifies that the reaction is taking place. But you may ask me, that sir, is that enough? Evolution of gas always signify that a reaction is taking place? No, definitely not. It is one of the criteria, one of the feature of a chemical reaction that gases evolve from a chemical reaction. But it is not compulsory that all the reactions will evolve gas. And if the gases are not evolved from a chemical reaction, it will be concluded that the reaction is not taking place. No, it's absolutely not. Evolution of gas is one of the parameters or one of the criteria feature of a chemical reaction. The next is evolution of heat. There are many reactions which evolves or gives out heat as a symbol that a reaction is taking place. Reaction is taking place. So a high amount of heat is generated when a reaction is going on. That's a feature of the reaction. One of the example given that methane or natural gas, when it burns in air, it gives out a lot of heat. It gives out a lot of heat, and that heat is very important in utilizing under many aspects of segments or sectors. The triangle sign is basically, by this time you know that triangle sign is a symbolic representation of heat. Coming to the next point, that is formation of precipitates. Formation of precipitates. We know that precipitation is or form insoluble residues are formed within a chemical reaction. So calcium chloride plus sulfuric acid, it gives calcium sulfate and hydrochloric acid. So calcium sulfate is insoluble. It precipitates out, it separates out from the reaction medium, leaving behind hydrochloric or acid as in the only liquid medium. The next is potassium bromide plus silver nitrate, KBr plus AgNO3 gives potassium nitrate plus silver bromide. Silver bromide precipitates out. Silver bromide precipitates out. Over there, calcium sulfate is a white precipitate. Silver bromide is a yellow precipitate. Light yellow. It's a light yellow precipitate. Silver bromide. Coming to the next point, that is change of state. That means we know that through three states of matter: solid, liquid, and gas. We know there are three states of matter: solid, liquid, and gas. And before the reaction and after the reaction, there will be a change of state. There will be a change of state. If we follow the reaction, examples given, that carbon and sulfur in the solid state, they react together. That means if they're heated together, they form carbon disulfide, which is basically a liquid. So carbon and sulfur, they're both solids, and when they're heated together, they form a liquid called carbon disulfide. So change of state occurs or taking place. Another example, that's a very simple, well-known, that's hydrogen plus oxygen giving water. So hydrogen is a gas, oxygen is a gas, water is a liquid. Water is a liquid. Coming to the next, that is change of color. Another important parameter or characteristics of a chemical reaction. It is before the reaction and after the reaction, there will be a visual, a prominent and a distinct color change occurring in the solution. So ferric chloride plus sodium hydroxide, giving ferric hydroxide plus sodium chloride. FeCl3 is a straw yellow color, and sodium hydroxide is a colorless. When they react together, they give a ferric hydroxide precipitate, which is a brown color precipitate. It's a brown color precipitate. Ferric hydroxide and sodium chloride. Now, another example of change of color, we can go for that. That is, for example, lead nitrate. We can take lead nitrate solution. And potassium chromate solution. So lead nitrate is a colorless solution. Potassium chromate, it's a yellow solution, light yellow solution. When they react together, they give a brilliant yellow precipitate of lead chromate. And okay. So with this, I'll stop for today's class. And another point which I want to mention, that is, with the previous chapter, the exercises and the exercises which you are doing, you do it in your exercise copies if you're having. There is no compulsory that you have to send it, the scanned copies, to any of the emails of the teachers. It's not compulsory. Keep it with you. Just do it. Keep your exercise books or the copies updated. So when the school will reopen, you will submit the copies for checking, and we will be collecting those copies for correction. All right? So that's all for today's class. Stay at home. Take care, very good care of yourself, and thank you.